Hi, I'm Steph Chavez. Today we're going to talk about constraints and constraint-driven design. Design constraints are basically physical and electrical rules that are implemented within the design, both of the schematic or the layout, that are derived from customer requirements. We need design constraints because they are the rules that govern in how a PCB is designed with the intent of meeting both physical and electrical requirements to help ensure that the final end product was designed correctly and correct by construction and meets the final engineering intent and achieves your customer's expectations, such as the CCA that I'm holding in my hand. We implement constraints by first capturing them in a document or getting this document from your customer that's agreed upon. Then what you do is you start deriving and how you're going to capture them, which I showed you here on the whiteboard. I have an example where I have nets, I have classes, and I have constraint classes. Then I start grouping them together so that way I have a cohesive rule base to govern my board. Then, as you can see here, I start actually implementing them within the database. Typically you do this in the front end, but today's capabilities you can do in both the front end and the back end. The key here is to control how it's being implemented and who is implementing them. The value add that we get from utilizing constraint-driven design or implementing constraints is that we increase the potential for success in meeting our design expectations, and it increases correct by construction methodology. It also is another way to ensure that you meet all required design intent to meet the final end product, such as a cell phone, which all of us have. The evolution of constraint-driven capabilities in today's tools are more powerful than ever before. We now have the capability in automation to utilize constraints to be more efficient and be more optimized in successfully designing complex PCBs from the perspective of layout solvability, performance, and manufacturability. For example, this is one of the winners of the XTIA competition this year. This is a constraint-driven design, and it is physically impossible to be able to design something this complex without implementing constraints. Thanks for tuning in, and I hope you now have a better understanding of the value of a constraint-driven design.